Today's lesson is on scatter plots and lines of best fit. And then we will do it algebraically today on some paper, and then tomorrow we're going to do an activity on our graphing calculators to see how we can do it on there. So first of all, scatter plots should not be something that's new. All right, it's just a graph with two sets of data that's plotted as ordered pairs on a coordinate plane. So if we look down here at this example, this is what we're talking about. Okay, so on the x-axis we have year, on the y-axis we have students per computer, and then we have plotted that information so that it's easy for us to see if there's any relationships between the two sets of data. Okay, and a line of fit is just a line that we could draw on our graph that would follow most of the trend of the data. It might not go through all of the points, but it would go in the general same direction. So when we do that, there are three types of correlations we'll look at. So we have a positive correlation, and then we have a negative correlation, and then we have no correlation at all. So if you look at positive correlation, we can see that all of our dots tend to follow a positive slope. You know, that direction of, if we read a graph from left to right, it's going up. A negative correlation will follow those points that have a general negative slope to them. And like I said, notice how the lines for positive and negative aren't going through all of the ordered pairs, but it's going through sort of the center of all of them. And then over here at no correlation, and this is a whole lot of ordered pairs, and you might not have this many, but there is no general positive or negative correlation going on with them. All right, so let's take a look at our first example. It says determine whether the graph shows a positive correlation, a negative correlation, or no correlation. And if it is positive or negative, we must describe it. So if we are taking a look at this, so it's computer sharing in Maria's school. So way back in 1997, there was about 37 kids who had to share a computer. So I would imagine that's like a big computer lab, and then kids just rotate through. And then if we go here to like 2005, 6-ish area, that has drastically gone down to where we are at like 7, okay? And if this is for our school, we would go out here to like 20, you're not gonna be able to read this. If we were to go out here to, 2020, it would be right here at 1 because we are a 1-to-1 school, okay? So, but I wonder, our graph might have looked like that over the years as well. So looking at this, I can see, hey, my trend or my data, it's sort of going negatively, which is good. So I would draw my line somewhere around there. Okay, now we do have to understand that this line will not continue down past the x-axis, because that would mean there's like a negative amount or a negative a negative number of students per computer, which just cannot happen. Okay, so there is a negative trend there. So what does that mean? Well, we've already sort of described it, is that, I'll do it over here, so let's write a negative correlation. And that means that the number of students per computer has decreased. Or the number of students sharing a computer. We'll put it that way. All right, so pause the video, take a second, try the your turn. It's along the same type line, so except to know what they're talking about, you're going to have to read the heading, just like we did here. See, look, what does the x and y axes each represent? Okay, so take a moment and do that. All right, so you can see I just said that there's a positive correlation. And as the years go by or the years go on, the number of mail order prescriptions is also increasing. Okay. All right, so now I've drawn the lines in our graphs, but now we are going to figure out how can I write the equations of those lines. Okay, so here are the steps. First thing we have to do is if they do not give us a scatter plot, we have to create that scatter plot from the data they've given us, okay? And then while we're creating that, we can sort of see, hey, are these ordered pairs forming any type of relationship between our data? Okay, so once we've initiated that, yes, there is a relationship, we're going to draw a line that seems to pass close to most of the points. Remember, I said it will not go through all of them. And then it says use 2 points that are on your line, okay, to write the equation for that line. And we've done that before. And then we can use our line or our equation to make predictions as to what might happen in the future. Okay, they really like these types of questions as open-ended questions on the Keystone, because you can see just from here, these 4 steps, how they can create like 4 different parts, A through D, and then have you use your values to create a prediction. All right, so here we go. It says the table shows the world population. We don't really need this. Growing at a rapid rate. All right, so draw a scatter plot and determine what relationship exists, if any. All right, so looking at all of this data, we have year and population. So year is going to be down, year is going to be down here. So year, and then population. All right, so this is generally the hardest part, trying to figure out how we can fit all of these on. So if I do 1650, 1750, 1850, 1950. Could work, but I want to make it a little bit better. Oops, I forgot my 0 there. Probably can make that a little bit better so that way, because we're going to have a whole bunch of numbers smushed there, but that's okay. That'll get us going. And now our population, we have to go from 500 to almost 6,500. So this is going to be pretty. So 500. It's not going to be enough, so we'll do every line is 500. So we'll do 2,000 there, 3,000. I'm going to add a line. Actually, we'd better not add a line. I'm actually going to start here with 1,000. All right, sorry, it's a little sloppy, but all right, we have all of our values on there. So now let's plot our points. So these are going to be a very rough estimate. So 1650, 500, we'll go about there. 1850 is at 1,000. 1930s was about there because it would be 1900. So 1930 goes up to 2,000, which I just realized I missed a 0. And I did that a couple times here. And there's 1,000. Okay. So then we did 1930, 1975. Wow, that's a big jump. And then 2004. We're up to almost 6,500. All right, so this set of data, you can see it is not linear. Because remember, linear is a straight line. And if I were to create a line that followed this, it would actually be what's called exponential, okay? It would really look like that. However, we don't know how to write those types of lines. So we are going to find or create the best line that we think for this set of data. So I would say try not to use the first point, because look what happens if I use the first point. If I do the first and the last, it sort of follows this trend. And is this point out here going to be the same as like going the normal trend? No, it's not. So you don't always have to have the first and the last point. So what I'm going to do is I'm going to sort of draw like through these two. Okay, so I feel like that's going to give me something a little bit closer. So I picked this point and this point. So there's my line that I drew. Part B is done. There is a relationship that exists. It is positive. So we're going to say positive correlation. And now it says write the slope-intercept form of an equation for the line. And it's telling us to use 1850 and 1000, 2004, and 6000. So this part here, and they picked points that I did not use. I didn't use 1850. I did the 1930, but that's fine. This is something they will do on the keystones for you. So now we have to write an equation. So here's my x1, y1, x sub 2, y sub 2. And our first step is to find our slope. So 6,400 minus 1,000 all over 2004 minus 1850. So this is step one. I'm just going to do this all at one time. So 6,400 minus 1,000. We know what that is. 5,400. But 2004 minus 1850. And it will give us our fraction all at once. And actually, I think I'm going to write this in decimal form. So our slope is 35.006. Okay. So now that we have our slope, we're going to use that and one of the ordered pairs. I'm going to use 1850 and 1000. So that's x, that's y. So we get 1,000 equals 35.06 times 1850 plus b, because remember it's our y equals mx plus b. So I'm going to take that times 1850. So 1,000 equals 64,870.13. I'm going to take 1,000 minus that answer. So B is negative 63,870.13. So then our final equation is y equals 35.06x minus 63,870.13. Now, if you're wondering, like, how can my B value be negative? Well, if you take a look at this graph that we drew, won't that sort of fit all the way down here negative? It doesn't make sense to our problem. I can't have a negative population, but if these values were to just represent anything or represent nothing, that would make a little more sense. All right, so take a moment, try this your turn. The numbers are a little bit smaller, should be easier to work with, and then come back and we will go over it. All right, thank you for bearing with me on that as my crayon decided to die. So hopefully you got something around 8x plus 1,104. Now your values might be slightly different than mine depending on which ordered pairs you used. But my point is that you should be sort of close. You shouldn't have like 27x or negative 15x. It should be somewhere around 8. Okay, maybe a little higher, maybe a little lower. And then your y-intercept will vary depending on what value you got for your slope. That's why with this on the keystone, they generally have a range of values you should have, or they will do like we did in the last problem and give you specific points to use. All right, so the last part here is going to be us using equations. And look, this equation here is very similar to what we got on the first one. And it is our prediction equation. So we got 35.06. Yep. Wow, we have almost the exact same thing. So now they're saying, hey, here's this equation I want you to use where X is the year and Y is the population of millions. Use that to predict the world population in 2010. So 2010, that's a year, so that's X. So that means all we have to do here is substitute 2010 in for X. So Y equals 35.1 times 2010 minus 63,935. So let's take our 35.1 times 2010. We'll do this step by step. So Y equals 70,551 minus 63,935. So minus 63,935. So does this mean the population was only 6,616? Because that doesn't seem right. But if we look back up here, this is in millions. So this is actually like 6.6 million. We'll just do 6.6 million people. Okay, and we could look that up. I know we have in the past and that's come out pretty accurate. All right, so last your turn, take a moment, look at this, and then come back and check. The one thing I will caution you on, it says X is years since 1998. So we're not just plugging in 2015. We actually have to find how many years is 2015 from 1998. Oh, and look, they did get the same exact equation as us. All right, so then we converted our answer since it's in thousands, and that's what we got.